All right, so this is your lab report for the KHP. This is for the purity of KHP. Now, if you're in my lab and I've decided to have this handed in as a double report, meaning the standardization of sodium hydroxide, you'll have the standardization of sodium hydroxide report before the KHP. Just staple all of it together and I'll grade it all at once. So just remember that note. But for page 1 for this report, you'll have the lab rubric that comes from Canvas. Page 2, you'll use the lab report form, which I'll refer to in just a moment. Page 3, you'll do calculations, but I only need representative calculations. So the second that you've done a type of calculation, like a conversion from, say, molarity to moles, I don't need to see it again. And then the last page will be the carbon copy of your data only. And that will be your KHP report. Again, if I'm asking you to hand it in as a double lab, I want the standardization report first, KHP second. So let's come over here and look at the overhead, because I want you to see a couple things about this. You need to write your balanced equation for this titration. You can find this in the preamble for your lab procedure, and it tells you to circle the analyte. That's what you're looking for. In the previous lab, standardization of sodium hydroxide, your analyte was sodium hydroxide. You needed to find its concentration. For this particular lab, you have a different analyte. Now note, molarity of sodium hydroxide used. This is the standardization of sodium hydroxide. This is where you're going to put that value. It should have 4 significant figures, and it should be close to 0.13 molar. If it's not, make sure you check with me about your calculations. And then down here, you're going to fill out this chart. Notice it has percent KHP. If you have a sacrificial run, one that you use just to determine roughly how much you needed before you slowed down in the second titration, you will not include that in these data sets. You'll just include the ones, the good titrations that you want to use. So for this lab, I think we'll have 3 of those, and then that's going to ultimately determine your average percent unknown. And don't forget to write your unknown number. The deviation, again, is going to be your average minus trial 1 absolute value. Trial 2, average minus trial 2 absolute value. Then you'll take the average of deviation of those. Now notice it asks you a few questions down here, and that's good. I'm not going to grade this one on precision, although a good value for parts per thousand is 3 parts per thousand. But don't worry, I'm not grading on this average deviation. And then you've got a question at the bottom to answer, so you'll fill out this full report form. So let's talk for a few moments about the calculations. You'll notice up here, I already have my KHP. Remember, this does not stand for potassium, hydrogen, phosphorus. This is potassium, hydrogen, phthalate. And so its molar mass, which was given in the standardization of sodium hydroxide lab, was 204.23, and we titrated it with sodium hydroxide. So to remind you of what you did, we had in the burette sodium hydroxide, for which you already have a concentration, it should be around 0.13. You've got your sodium hydroxide in here, and in the Erlenmeyer, you have your KHP sample. Now that is a sample in the sense that you have KHP in there and other stuff. So it is not a pure sample of KHP. Your goal is to find out what is the percent of KHP in your sample. That is your goal. You got to figure out how much of that white substance, the white powder, was actually KHP. So to do that, you will start with the concentration of sodium hydroxide. This is going to be from your lab, so it should be roughly 0.13. And to do this, you've got to figure out how many equivalents did I actually deliver to get to the end point here, which was your faint pink. And so let's say that I used 24.15. So again, this is in liters, so 0.02415. And that's going to get me to the moles of sodium hydroxide. But I can't stop there because, again, I want to end ultimately with KHP. Well, the only other relationship I have between sodium hydroxide and KHP is my balance equation, which tells me for every 1 mole of sodium hydroxide, I end up consuming 1 mole of KHP. So lo and behold, when we end with this answer, I'm going to bring it back over here, I'm going to end with moles of KHP. But I want to end with a mass percent. Hint, hint, mass percent. So I cannot leave this in moles of KHP. I've now got to take that and do a conversion to grams of KHP. So here we've got a molar mass conversion. And now I finally have the mass of KHP in my sample, but I don't have the percent. Now remember, for your lab report, you ended up massing out KHP sample. That means the KHP plus a powder. So what you're going to do in your last step to get to that percent KHP is you're going to take the mass of KHP that you just determined, so this right here, and you're going to divide it by the mass of your total sample. That's your KHP sample that had the unknown number. And of course, then you'll multiply it by 100. And that's going to be your mass percent of KHP. And you'll do that, of course, that calculation for however many titrations that you determined. And then you'll find the average and so forth. And that's the total of the lab report.